Are you a student filmmaker or an indie cinematographer? Then you surely need a smoke machine on your art house, avant-garde, passion project, no budget music video shoot. But what now? You're filming it in Unreal? Unfortunately, Unreal Engine doesn't come with a smoke machine, but I got you covered. I'll show you how to make this volumetric fog step by step in detail. So the first part will be making the material and the second part will be making the blueprint. This particular method is using volume textures instead of 2D textures as the mask. I think this makes the fog look more believable, especially up close. Just a quick disclaimer, this method of making volume fog has been shared extensively by Asher Zhu and Ryan Brooks in their blogs a few years ago. The method I'm showing here is just something I've mixed and matched for my liking. Firstly, go to Edit, Plugins, search for Volumetrics, and enable the Volumetrics plugin. You can see I already enabled mine, and restart the engine if you need to. In the content browser, I'm going to make a new level and I'll call it Level Fog Tutorial. And in this level, I'm going to open the Environment Light Mixer window and add all the environment actors I need. I'll place them in a folder so they are organized. Let's also add a post-process volume. And in the post-process volume, go to the details panel, search for bounds, check infinite extent, and then search for EXP and set the minimum and maximum to 1. So we have an even exposure in the level. I'm just going to use a block mesh to lay it on the ground, so I have a flat surface to work on. Doesn't really matter what you use here. In the content browser, I'm going to click on Content and search for third person. I'm going to drag in the mannequin so I have a reference for scale. Back in the content browser, go to the settings menu on the far right and make sure to check Show Engine Content and Show Plugin Content. Now in your folder tree, if you go to Engine, Plugins, scroll all the way down, find Volumetrics Content, Content, Volume Textures, and Textures. And these are the volume textures we'll be using to make the fog today. In the content browser, I'm going to make a new folder called Volume Fog Tutorial. I'm going to keep pretty much everything in this one folder. Let's make a new material and name it m_volume_fog_tut for tutorial and double click to open it. Firstly, let's change the material domain to volume. And we also need to change the blend mode to additive. So now I'm going to make the base function for our local volumetric fog. So let's right click in our graph and search for local position, which is under miscellaneous. Right click again and search for object local bounds. Right click again and search for the subtract node and connect the local position to the A and local bounds minimum to B. Hold D, the D key on your keyboard, and left click for a divide node and connect the result and divide that by the local bounds size. Right click again and search for distance. Scroll down, it's under utility. Connect the result and press 1 and left click for a constant node and change the value to 0.5 and connect it to B. Press M and left click for a multiply node, connect the result to A, and press S and left click for a scalar parameter, and let's name the parameter fog edge roundness and set the default value to 2. Right click and search for 1 minus and connect it to the result. And then we're going to connect this to the extinction, but just before that, press M and left click for a multiply node, and press S and left click for a scalar parameter, and name the scalar parameter fog overall density. And I'll set the default value to 1 for now, and connect it like so, and the final result to extinction. I'm going to grab these nodes, maybe up to here, and press C to comment, and we'll name this volume fog function. Press save, and let's go back to our level. I'm going to drag in a cube and make the scale 20 by 20 by 8. Let's go back to our material in our content browser. I'm going to right click on the material and make a material instance. And I'm going to drag it on the cube to apply it. And you can see nothing is happening because volumetric fog is not enabled. So it's quite important to note, for this function to work, you have to have an exponential height fog in your scene. And if you click on your exponential height fog, in the details panel, if you scroll down, there's a section called volumetric fog. And if you tick the box to turn it on, you should now be able to see the volume fog you made in the material. And my fog looks black because I haven't set the color. So let's double click on the material to open it back up. So I'm just going to get a constant node, set it to 1, and connect it to the albedo for now. And save and go back to our level. And we now have a very basic volumetric fog working in our level. In the details panel, double click on the material instance to open it. You can play around with the density values to make the fog quite thin or quite thick. Now I want to make the fog a little bit more believable, so let's open up the material, right click and search for world position. Press M and left click for a multiply node and connect the XYZ world position to the A and set the B value to 0.0001. And let's get another multiply node and press V and left click for a vector parameter. Name it base fog tiling. Connect it to the multiply node, and I'm going to set the default value to 222 for now. Press A and left click for an add node, and press M and left click for a multiply node. Right click and search for time. Connect time to the A and press V and left click for another vector parameter. Name it base fog pan. Set the values 0.02, 0.03, minus 0.001 and connect it to the B. So this will control the speed and direction of the fog. Now let's go back to our content browser And let's go to Engine, Plugins, Volume Matrix Content, Content, Volume Textures, and Textures. Or you could just go to the root and search for Perlin Whirly. So VT Perlin Whirly Balanced is the one we are looking for. So if I drag this to the graph, like I would normally do with other textures, I get a texture sample node, and this isn't what we really want to do with volume textures. What you need to do is right click and search for volume texture and get the texture sample parameter volume. And let's name this base fog VT. You can see that the engine is automatically using the Perlin Whirly volume texture because it's the last one that we clicked on. But to be safe, I want to create a copy of this volume texture and use the copy and not use the original. So I'm just going to delete this for now. So let's drag this volume texture to the volume fog tutorial folder, and I'm going to choose copy here, and you can see it's being copied over. Back in our graph, let's search for texture sample parameter volume and name it base fog VT again, and connect the result of the add to the UV. So if you click on the volume texture sample and go to the details panel, you can double click on the texture to have a closer look. In this window, you can click on the 3D view to view the texture in 3D. So you can scroll in, zoom in, and drag the cube to view the texture in 3D. So let's finish our mask function. Right click and search for power, and let's connect the red channel to the base of the power node. And let's get a multiply node and connect the power to the A. Press S and left click for a scalar parameter, name it base fog contrast, and set the default value to 2.3 and connect it to the power. And get another scalar parameter, name it base fog intensity, set the default value to 0.7 and connect it to the B of the multiply node. So somewhere in the middle, press M and left click for a multiply node and connect the result of the mask to the A. Hold down Ctrl, left click and drag this pin to the B to change the connection, and connect these like so. And like before, I'm going to grab these nodes and name it base fog. I'll just move this over here. Let's save and go back to our level. So you can see this needs a little bit of tweaking. Let's open up the material instance and try changing some of the values to make this more visible. So I've increased the base fog contrast and base fog intensity to see what is going on a little bit more clearly. I think I need to change the default tiling, so let's change this to a higher value so we can actually see the texture. Now you can see the mask a little bit more clearly. So these parameter values will most likely depend on your situation and the volume texture that you're actually using. So if something looks wrong, be sure to play around with the values to get the result that you want. And I can change the value of the pan to make it much faster, or change the direction of the movement. Back in our material graph, I want to add another layer of detail to this fog. So I'm going to grab these nodes from the base fog and press Ctrl D to duplicate. Let's connect the XYZ value to the multiply exactly like the first one. I'm going to change the names of these parameters. So it's detail fog tiling for this one, and detail fog pan, and obviously detail fog VT, detail fog contrast, and detail fog intensity. I'm also going to change this connection to the green channel. If you look in the texture, you can see that there are different types of noise embedded into the different channels. Actually, let's make the first one use the green channel and the second one use the blue channel. So green channel for the base fog and blue channel for the detail fog. So somewhere around here, press A and left click for an add node. Add the first and second mask together and replace the connection to the multiply. And I'm going to grab these nodes, press C and name it detail fog. I'm going to tweak the values of the detail fog so that it's different from the base fog. So let's set the detail fog tiling to 555. Actually, let's set the base fog tiling to 444. And let's change the detail fog pan to 0.01, 0.02 and leave the B. Let's save and go back to our level. So this is looking a bit better. You can see there are two levels of detail in this fog. I'm going to open the material instance again and play around with the values a bit more until I find the look that I want. So I'm going to turn off the base fog intensity, set this to 0 for now, so we're only looking at the detail fog. And in the viewport, you can press L and left click to bring in a point light quickly. And I'll use this light to see the fog a little bit better. Now I'm going to set the detail fog intensity to 0 and set the base fog intensity to 0.6. So now we're only looking at the base fog. I've now adjusted the tiling values. I'll turn the detail fog intensity back up to 0.4 so we can view the two together. In the details panel of your point light, there's an option called cast volumetric shadow, and if you turn it on, you can see that the shadow that this light creates is affecting the fog. Last thing I want to do before moving on is in my cube, I'm going to search for collision. And in the collision presets, I'm going to set this to no collision. This is so that the cube doesn't affect the gameplay. Let's make a function to control the color of the fog. In our material graph, press V and left click for a vector parameter, name it fog color. And I'll make this white. Let's duplicate this one and name this fog shadow color, and I'll set this to black and duplicate this again, and we'll name this fog top color, and I'll just make this blue. Can be any color you want, just make it different to the fog color. Press L and left click for a lip node, connect the fog color to the A and the fog shadow color to the B, and use the combination of the two masks as the alpha. Press L and left click for another loop node and connect it like so. And for the alpha here, we're going to get the height value of the volume fog. So search for a component mask. In the details panel, unclick R and G and only check B, and come out of the divide into the component mask and press M and left click for a multiply and connect the mask to the A and set the B value to 1.5. Right click and search for a smooth step node. And connect this one to the value. S and left click for a scalar parameter, name it color gradient bias, and set the default value to -0.08. Right click, search for a subtract node, and connect this here and leave the A. Right click, search for a max node, and set the B value to 0.01 and connect this to the A and this one to the max. Right click and search for a subtract node and connect it to the A and connect the result to the min, and use this for the alpha of the second loop node. And let's connect the output to the albedo. Save, and let's look at our level. Looks like I have the fog color and fog top color other way around. So back in my graph, I'm going to change the B and A connection here. This should fix it. And back in my label, you can see the fog top color, which is blue, is showing on top. And as it gets to the bottom, it becomes white, which is the main fog color. And you can control the blending by the color gradient bias parameter. And if I set the fog shadow color to something like purple, you can see there are bits of purple fog floating with the main fog color. I'll just set this back to black. Again, I'm going to grab these nodes and name this color, actually fog color. Now I want to add another function so the fog kind of hugs around the static meshes around it. I'll do this by using mesh distance fields. In my material just above the volume fog function, I'm going to right click and search for distance to nearest surface. Press S and left click for a scalar parameter, and I'll name this distance. And I'll make the default value 1400. And let's get a subtract node. So this will control how far the fog extends out from the surface of the static mesh. Press L and left click for a loop and connect the distance to the A and let's get another scalar parameter and call this edge hardness and plug that into the alpha. Press D and left click for a divide node and connect the result of the subtract to the A, and then connect the result of the lerp to the B, and right click, search for a subtract node and connect the result of the divide to the A, and press A and left click for an add node and connect the result of the subtract to the A. Now get the output of the volume fog function and the masks multiplied together and connect that to the B, and reconnect the pins like so. I'm going to grab these nodes that I just made and call it distance fields. Let's save and go back to our level. And let's open up our material instance. I'll increase the density so we can see things clearer. You can now see the fog reacting to the surfaces around it. I'll adjust the tiling and the contrast values of the fog again, so it's a little bit more visible with the new function. You can see when I decrease the value of the distance, the fog sticks closer to the surface, and when I increase it, it extends out from the surfaces a bit more. I'll leave this at 1400. I'm going to keep the edge hardness at a very low value, so I'll leave it at 0.02 for now. So the fog material we made so far works quite well when there is light, but when there's no light or when the fog is in the shadow, it kind of disappears. Fortunately, you can make your volume fog also emissive. So let's go back to our material graph and we'll adjust the color function to have the option to make it emissive. So press M and left click for a multiply and change the B value to 0.001. Press L and left click for a lerp node and connect it like so. And for the alpha, let's get the output of this add node and plug it in. Right click and search for a static switch parameter, and let's name it use emissive. And connect the output of the lerp to true. Hold 1 and left click to get a constant node, and let's just plug a 0 to the false. And connect the output of this to another multiply node. And let's get a scalar parameter and name it emissive amount. And I'll make the default value 0.1 and connect the output to emissive color. Let's save and go back to our level. When I open up the material instance and check use emissive, if I turn it on, it doesn't look very different at the moment, but if you increase the emissive amount, you can see that the fog is now emissive, and you can make it more visible in the shadow or in the dark. But for my use, I'm going to keep the emissive amount at a very low value like 0.1, just so that it doesn't completely disappear in the shadow or the dark. Now, to give the fog even more variation, I'm going to add a curl texture to the material. So in your content browser, go to the root and search for curl noise. And you can see there's a VT curl noise. And I'm going to drag this to my volume fog tutorial folder and copy. Right click and search for texture sample parameter volume. And let's name this curl noise VT. Double check that you're using the one you've copied. So I'm going to grab these nodes here and copy it before my curl noise VT. And let's connect the XYZ position to the multiply like the others. And let's get rid of this vector parameter and replace it with a scalar parameter and name it curl scale and set it to 0.15. Let's add another multiply node, M, and left click over here and connect it up like so, and set the value of the B to 0.0001. And let's rename this vector parameter to curl pan and set the values to 3, 3, 1 and connect it to the UV. Let's right click and search for a static switch parameter and name it use curl. Press M and left click for a multiply node and connect the RGB to the B, and for the A, get the XYZ value of the world position node and connect the result to true, and get another pin out of the XYZ and connect it to the false, and connect the output of this to the start of our base fog. And let's select these nodes and press C to comment and name it curl noise. Save, and let's go back to our level, open up the material instance and turn on use curl. You can see that the fog changes shape drastically, but it looks a little bit too random at the moment. Also, one thing I forgot to do is that I want to be able to turn the mesh distance fields on or off in this material. So I'll add another static switch parameter and call it use distance field. Connect the output of this add node to true and connect the output to the multiply and connect the output of this multiply to the false. And I'll set the default value to on. Save, and let's look at our level. So in our material instance, I can now turn off distance fields. And I'll turn on use curl. And you can see the shape of the curl noise much better. And if you change the value of curl scale, you can change the shape of the curl noise, which is basically the tiling. And you can play around with the curl pan values to change the shape and direction of the noise as well. Okay, so you can stop here if you want and just use the fog as it is now. You can control the parameters from the material instance, but If you want to have more control and easier access, it might be more practical to make this into a blueprint. This blueprint is not very complicated at all. It just takes a bit of time to make because there are quite a few parameters to hook in. Let's go to our Volume Fog tutorial folder. In this folder, right-click and go to Blueprint Class and choose Actor. Let's name this BP Volume Fog. Double-click on the blueprint. And in the Components tab, let's add a new static mesh. And for this static mesh, we're going to use a cube, but I'm not going to use the default engine cube. Just to be safe, I'm going to make a new one. So let's go to modeling mode and choose box and just click anywhere on your viewport and press OK. And just to keep things tidy, I'm also going to move this cube to my Volume Fog tutorial folder. Let's go back to our blueprint. So I'm going to select the cube that I just made in my content browser. And by clicking on this arrow here, I'm going to put it into my static mesh component in my blueprint. And in the scale, I'm going to set the X to 20 and Y to 20 and Z to 10. Now we just need to set the cube to use our fog material. But the thing is, we have some static switch parameters in our material. So the way I'm going to do this is make different versions of the material depending on where the switches are, and then use those different versions of the material and allow the user to switch between them in the blueprint. So in my content browser, let's right click and create a new folder, and let's name it Volume Fog Material 4BP. And I'm going to copy my Volume Fog material to my new folder. And let's rename this material M_VF01_base. Double click to open this material. I'm going to make sure all the static switch parameters are set to off by default, except for use distance fields. Save, and let's go back to our content browser, and I'm going to duplicate this material and name it VF02 emissive and double click to open. And I'm going to check use emissive, so default value on, and save this one as well. And let's duplicate this first one, VF01 base, and rename this VF03 and curly. Double click to open, make sure emissive is off, and we'll check use curl on by default and save. And now duplicate the curly and name it M_VF04_curly emissive. Double click to open the material and check use emissive on and make sure use curl is also on. Save the material. So we have 4 different types of materials now, which are all using distance fields, but one is not emissive and not curly, and one is only emissive, one is only curly, and one is curly and emissive. To use these in my construction script, I need to make an enumeration. So right click in your content browser and search for enum. Let's name it enum_VF underscore mat. So think of this as making a list for a drop-down menu in your blueprint. So click on Add Enumerator. Let's name the first one Base Fog. And in the description, I'm just going to put in Base Fog without emissive or curl. Let's add another enumerator and name it Emissive Fog. And description, Emissive Channel Activated. Add another one, let's name it Curly Fog, and curl applied, not emissive. And for the final one, Curly Emissive Fog, and curl applied and emissive. And save and exit. In your content browser, let's go back to our volume fog tutorial folder and open up the material instance that we made before. So remember all these parameters that are in the material instance? We want to make all of these material parameters as variables in our blueprint. This is going to be pretty boring if you already know how to do this, so feel free to skip ahead. In the variables window over here, click on the plus sign to add a new variable. We're going to mirror all the parameter names from the material to the variables. So let's name the first one Fog Overall Density and set the type to float. Click on this new variable and let's go to the details panel. You can set the range and the default value and also the category so it's organized. Click where it says default and I'll type overall fog, and that creates a new category. And for the slider range, I'm going to set it to 0 to 10. And let's add another variable and name it fog edge roundness. And this is a float. Click on the arrow next to default and I can set it to overall fog, which is the category I just created before. I'm going to set the slider range 0 to 2 for this one. Let's compile so I can actually set the default values. For the fog overall density, I'll set it to 5. And for the fog edge roundness, I'm going to set the default value to 2. Compile and save. And let's keep going. Add a new variable called base fog tiling. And the type for this has to be a vector. And let's add a new one called base fog pan, which is also a vector. Let's compile and let's set the tiling values to 222 and make a new category called base fog. And for the base fog pan, you can drag it here to put it in the base fog category, and let's mimic the default values that we had in the material instance again. So 0.03, 0.03 and minus 0.001. Compile and save. Add another variable called base fog contrast. This is a float, and another one called base fog intensity, which is also float. Compile and save. And contrast, the default value is 3.9 and intensity 0.7. And let's put them both in the base fog category. Compile and save. Next up is color. Let's add a new variable called fog top color. For this one will be a vector, and let's add a new one called fog color, and finally fog shadow color, so 3 vectors. And another one called color gradient bias, which is a float, and yet another one called emissive amount, which is also a float. So for fog top color, let's make a new category called color, and let's move all these ones into color. compile and save. For the fog top color, actually I've made a mistake. Let's change the color variables, linear color instead of vector. So click on where it says vector and search for linear color. Click on linear color. And let's do the same for fog color as well as fog shadow color. Click compile. And for the fog top color, let's make the default color a light blue. And for the fog color, let's make the default white. And for the fog shadow color, let's leave it at black. Compile and save. For the color gradient bias, let's set the default to -0.3. For the emissive amount, let's set the default value to 0.1. Compile and save. For the curl noise, let's add a new variable called curl pan, which needs to be a vector. And let's add another variable called curl scale, which needs to be a float. Click compile. And for the curl pan, let's set the default values 331. And for the curl scale, let's set it to 0.15. And in the curl pan, let's make a new category called curl noise. And let's drag the curl scale into the same category. Now for the detail fog, let's add a new variable called detail fog tiling, which is a vector, and detail fog pan, and detail fog contrast, and detail fog intensity. Set the tiling and pan to vectors. And let's make a new category called detail fog and move all these into the new category. Click compile. And for the detail fog tiling, let's set the default values to 444. And for the detail fog pan, let's set the values 0.01, 0.02, -0.001. For the detail fog contrast, we'll set it to 4.3. And for the detail fog intensity, we'll set it to 0.4. Compile and save. Okay, almost there. For the distance, let's add a new variable called distance, which needs to be a float. And add another variable called edge hardness, which is also a float. And click compile and save, and let's make a new category called distance fields. Set the default value to 1500, and for the edge hardness, let's set it to distance fields as well. And let's set the default value to 0.01. Compile and save. So that's all my material parameters added as variables in the blueprint. Oh, I actually forgot we need to add our enum as a variable as well. So add a new variable, let's name it fog types. And in the variable type, we need to search for the name of our enum, which was enum vf mat. So click on this. So we have a new variable which the type is set to the enum that we created before. Double click to open the enum. I'm just gonna update the description. Let's write types of different volume fog materials. Finally, in our construction script, right click and search for switch on enum vf mat. You can see our enum list is made into a switch. Let's drag the fog types variable here and click on get fog types and connect it to the selection and connect the execution pin. Let's drag a pin out of the base fog and search for set material and click on set material static mesh. So every time a switch happens, a different material is set according to the different enum. So in the content browser, select the VF1 base and under material, click on this arrow in the node to insert it into the set material node. We're going to do the same thing for the other materials as well. So out of the emissive fog, set material static mesh, and in the content browser, select the emissive and slot it into the second set material node. And let's just duplicate this one, plug it into the curly fog, and for the third one, let's select the VF3 curly. Let's duplicate this one more time and plug it into the final pin and make it VF4 curly emissive. So let's go back to our material instance and look at which parameters belong to which enums. So for the second enum, which is the emissive fog, we have just the one scalar, which is the emissive amount. And for the curl, we just have curl pan and curl scale. And for the curly emissive, obviously we have the two combined, so 3 different parameters. So let's set those in our construction script to begin with. So drag a pin out of the set material of the emissive fog and search for set scalar parameter value on materials static mesh. And in our variable list, let's drag the emissive amount and click on get and plug it into the parameter value. And for the parameter name, we're going to copy the same name from the material parameter, which is emissive amount. So it's really important that you don't make any spelling mistakes here for this to work properly. So for the curl pan, because it's a vector, we're going to search for set vector parameter value on materials static mesh. And let's drag the curl pan variable and click on get curl pan and connect it to the parameter value. And same thing, enter the parameter name as curl pan. Now we need another set scalar parameter value on materials static mesh node. I'm not going to say the full name from now on. So set scalar node and connect it to the third tree, and let's drag the curl scale and click on get and connect it to the parameter value and set the name as curl scale. And for the fourth material and tree, I'm going to select these nodes and duplicate them down here, and I'll just connect them to the execution pin. I'm just gonna do some tidying up. I'm gonna select the second tree, press C to comment and name this emissive fog. And for the third one, press C and name it curly fog. And for the fourth one, press C and curly emissive fog. If you haven't fell asleep yet, you'll notice that we still have a lot of variables left to set up. To keep the main graph clean, I'm going to make a separate function for the base fog variables. So in our functions window, click on the plus sign and let's name the new function base fog parameters. In our base fog parameters function window, let's right click and search for a set scalar node. Right click again and search for a set vector node. So basically we need a lot of these two nodes. From our variables list, let's drag the fog overall density, click on get, and let's duplicate a scalar node and plug it into the execution pin and plug this into the parameter value and set the parameter name as fog overall density without any mistakes. And let's do the same for fog edge roundness. I'm just going to duplicate this and drag in fog edge roundness. Click on Get, connect it to the parameter value, and enter the parameter name as fog edge roundness. Drag the base fog tiling variable, click Get. Let's make a separate column for our vector parameters. Duplicate this one and connect it to the parameter value and enter the name as base fog tiling. I'm going to duplicate the set vector node one more time. I'm going to get the base fog pan variable, connect it to the parameter value, and enter the name as base fog pan. Let's get the base fog contrast and copy the scalar nodes and set the name as base fog contrast and connect it to the parameter value. Let's get the base fog intensity, copy the scalar node and connect it to the parameter value and enter the name as base fog intensity. For the fog top color, let's get the fog top color and copy a set vector node and enter the name as fog top color. And if you connect a linear color variable to a vector parameter value, it will automatically use a translator node to connect. Let's get the fog color, so same story. Duplicate set vector node. Let's set the parameter name as fog color and connect the variable like so. Let's grab the fog shadow color, get fog shadow color, and duplicate these and name it fog shadow color and connect it up like the others. Okay, not long to go. Let's keep going. Let's get color gradient bias, duplicate the node, connect, and name color gradient bias. Let's get detail fog tiling, duplicate the nodes, name it detail fog tiling, and connect to the parameter value. And let's get detail fog pan. Same thing, duplicate, connect, and rename detail fog pan. Let's get detail fog contrast, duplicate, rename detail fog contrast, and connect the parameter. And let's get detail fog intensity, duplicate, connect, and rename to detail fog intensity. Wake up, almost there. Let's get distance, duplicate, connect, and rename to distance. Get edge hardness, duplicate, connect, and rename to edge hardness. Compile and save. And now we need to connect all the execution pins like this. So it doesn't really matter which order, just make sure all the nodes are connected somehow. I'm just doing it in a way that looks tidy to me. So I've connected all the pins, just double checking everything is connected. Let's compile and save. And let's go back to our construction script. So from our functions window, I'm going to drag base fog parameters function and let's connect it like so. I'm going to grab these nodes, press C to commit and name it base fog. And also because of how I planned this blueprint, we need to add the same function to the end of the other trees as well. So I'm going to drag the same function and connect it to the second tree, drag it again and connect it to the third tree, and finally drag it on again and connect it to the fourth tree. We're almost done. Let's compile and save. So back in our label, let's delete this cube. And in the content browser, from our volume fog tutorial folder, let's drag the BP volume fog into our label. You can see that the fog is working, but we can't see any parameters in the details panel. So in the content browser, let's open up our BP again. And in the variables tab, we can make all these variables public by clicking on these eye icons. Click compile and save. Let's go back to our level. So when you select our BP volume fog, you can see in the details panel, you can choose the fog types and you can control all the parameters of the material from this window. I'm just double checking that everything is working as intended. Finally, there's a console variable that you can use to increase the quality of the fog. So press the tilde key, go r.volumetric_fog.grid pixel size. And if you go space and question mark, and you can see what it is set to now, which is the default. So grid pixel size at 8. This is the default. So let's change it. So volumetric fog grid pixel size space 4. And I'm not sure if you can see in the video, but it definitely improves the quality of the fog, especially around the edges. However, this does take a big performance hit, so use it sparingly. Also, don't set this value lower than 4, it will probably crash your machine. Okay, one last thing I keep forgetting to do. Let's open our blueprint back up. In the Components tab, select the static mesh. And in the Details panel, search for Collision. Set the collision preset to No Collision. Compile and save. This fog surprisingly wasn't as costly as I thought it would be. But of course I'm no optimization expert. Fog is usually quite expensive to render because it means a lot of pixels have to be constantly updated based on a lot of different factors. One thing to note is that I couldn't get the fog to self-shadow properly. I'm using the fog shadow color as a half-assed attempt at the fog shadow, but it's nowhere near the look I was thinking of. If anyone knows more about making volume fog self-shadow, please do let me know. I'll be forever grateful. I hope this tutorial was useful for you. I'd love to see how you guys use it in your work. Please tag me if you upload something. And finally, repeat after me. Fog makes everything look better.